Hello and welcome to m253 Calculus 3 at Cañada College. My name is Lapuz. Welcome to section 4.5. In this video we'll look at checkpoint 4.23, and here they want us to calculate the derivative dz dt given the following functions. We have z is equal to x squared minus 3xy plus 2y squared, and then we have x of t is equal to 3 sine 2t and y of t is equal to 4 cosine 2t. Now this is we're gonna use a chain rule, and our chain rule tree tells us that f or z is a function of x and y, and then each of these are functions of t. And if we follow the path going from z to the t, and we're looking at the partial derivative of z with respect to x, and then here, since x is only a function of one variable, we can look at dx dt with straight derivatives. Now back here, z is a function of two variables, so these things have to be partials. And we'll see that happen here as well when we find the derivative of z with respect to y. And those are partial derivatives, and here are straight dy dt derivatives. So the value or the expression that we're looking for is not the partial but the straight derivative, because z is eventually a function of just the variable t. So this is a straight derivative dz dt, which is equal to the partial derivative of z with respect to x times the straight derivative dx dt plus the partial with respect to y times the straight derivative of y with respect to t. Okay. So we'll find each of these components and then do the product. Okay, let's find the partial of z with respect to x and then with respect to y. So with respect to x, we're going to get 2x minus 3y, and then the other one's constant 0. And the partial of z with respect to y will be 0 minus 3x plus 4y. Okay. Now let's look for the straight d derivatives. The straight d derivatives, dx dt is going to be the derivative of x with respect to t, so that's going to be positive cosine 2t times 2, and then there's a 3 out there, so we'll just call that a 6 cosine 2t, and then the derivative of y with respect to t, again straight derivatives, is going to be derivative cosine is negative sine, and then there's a 2t, so an extra 2 would come out and be an 8 with a negative cosine 2t. Okay, now we'll just put it all together. We'll call it the straight derivative d, remember, dz dt is going to be 2x minus 3y times 6 cosine 2t plus minus 3x plus 4y times negative 8 cosine 2t. And usually we want to have it eventually in the variable, in the independent variable at the end. So we would plug in the original function, which is 3 sine 2t for x and 4 cosine 2t for y. So let's do that. We have 2 times 3 sine t 3 sine 2t minus 3 times 4 cosine 2t times 6 cosine 2t. That's the first one. And the second one is negative 3 times 3 sine 2t plus 4 times 4 cosine 2t. And we have a negative 8 cosine 2t. Okay, well, we can leave it like that, or you can try to simplify it if you want. But I'll leave it like this. But I do want to show you that this is using the chain rule. What you could have done from the beginning is to actually see the composition. So we could have had z is equal to the composition of f, and where you put in x of t comma y of t, and you'll notice that z now is just a function of t. So let's see, we have x is actually equal to 3 sine 2t, and our function is x squared minus 3 times 3 sine 2t times cosine, or 4 cosine 2t. And then we have 2 times, and that is 4 cosine 2t again, but this time the y is being squared. So you could have had this scenario, and you could have taken the derivative of this thing, dz dt, since z is really just a function of one variable t. If you look at this, this is just one variable. So let's just let me just do a quick simplification here before I take the derivative. The middle term will be, we have 3 times 3 is 9 times 4. 9 times 4 is 36, so this would be 36 sine 2t cosine 2t. Alright, everything else we'll work with. So if we take the derivative of this, this is going to give us 3 sine 2t to the first power times the derivative of the inside, which is going to be negative 3. Oops, the derivative of sine is positive cosine, and again you'll get a 3 times 2, that's 6 cosine 2t. Here you'll have a product rule. We get 36, and then derivative of the first is cosine 2t times 2 times the second, cosine 2t, plus the first. Let's keep the 36 out here, plus the first, sine 2t times the derivative of the second. So it's negative 2 sine 2t. And then the last term, there's a 2, and then you bring that 2 down, so you get a 4 times 4 cosine 2t to the first power times the derivative of the inside, which is negative 8 sine 2t. Okay, so we didn't work things out, but if you match this up, you can see the terms that we have in common here. You can see that we have this term times this, and we have this term times this, and then these two terms over here will just match up with this big expression over here. In any case, they're going to end up being equal to each other. So this method of doing it tells us to put the function in first and then just do the regular derivative, and we're doing the kind of the chain rule implicitly happening in here, whereas in this method we're actually using the chain rule from the beginning. and we're employing the chain rule and coming up with a formula for the chain rule without actually doing the composition. Okay, and I think they want us to do it the first way. The second way is just to be able to check our work and to see the relationship between the composition of functions and how this relationship between z, x, y, and t is related as a composition versus just using the chain rule. Okay, I hope that helps.